Now it's lost.
No, I was writing notes. So
Oh, good,
I
good,
wrote
good.
a section called warming up the coffee. So I was taking notes. Uh, Super. Just one thing, Niraj, uh, could you, if possible, could you set your webcam on? There are only two requirements to join this meeting. Well, there are three of them. The first one is to be human. The second one is to bring coffee or whatever beverage you prefer. And the third one is, in order to double check
Sure.
that the first one was fulfilled, to set your webcam on.
Okay,
So,
I need to join through my laptop. Give me 2 minutes.
okay. I mean, if it's, don't worry. I mean, so super. And regarding, yeah, let
Also, get
me,
a T-shirt.
yes, I mean, uh, however you feel you are presentable to the world, just go ahead. And just let me check. So basically, the topic for the Monday Coffee for today is something that Marius and I have been discussing for, again, for weeks, months, which is RAG, right? This retrieval augmented generation systems, which in a nutshell, I mean, let me share my screen. I think it's going to be easier. Here we are. What is a RAG system? I mean, RAG system is in essence, well, LLMs are very cool, but if you want to make them work for your particular use cases using your internal knowledge databases, which is especially important in the enterprise, right? Enterprises have collected over the years like colossal amounts of data, uh, structured one and unstructured one. And let me share my screen. And what happens is that you want to somehow make this information more accessible to human operators, for example, to accelerate their day-to-day work or access information, right? So there are, I mean, it's basically building AI systems that can extract, serve, and reason more or less using that private information. And as we all know, LLMs out of the box are not able to provide that functionality. So the thing that everyone is doing is, well, if the LLM is not able to answer my requests with regards to very specific data, client data information. Of course, Llama 70 billion models is a great model, but if it does not have access to my database, it won't work. Well, the idea is here is, okay, in order to have the LLM, what we do is we need to build some previous steps and infrastructure to make this data available, which means that we put it in a data store, a vector DB, or a Postgres database or whatever state storage database where this information can be saved and retrieved. And what we do is we retrieve based on the user query, right? So based on the user query, we either use like a vector database or a whatever, a text to SQL to extract the data we need. We insert that into the prompt, and now we ask to the LLM, given the question, so this is the question, and given this context that we fetch from that particular user or question-specific information, what's your take on this, right? So what's the output? And the output can be, I don't know, whatever. It can be a chatbot, which is, let's say, one of the first applications, or what I think makes more sense in the real world is to extract structured information, which means systems that can, based on basically human queries, can extract data in formats that can be used downstream, whereas, for example, by agents or basically structured information like JSON in a nutshell. Okay, so what I'm showing here, basically one of the charts that we saw. This chart was built by NVIDIA. I'm going to show you quickly, and or Marius, a bunch of blueprints, which is, as we talked last week, NVIDIA is a GPU provider, but now it's also trying to, obviously, to accelerate the usage of their hardware. They are providing software which is specially designed to basically help you run LLMs on their hardware, right? And they have these NIM containers, which you probably know. So NIM containers by NVIDIA, which basically is a collection. These are basically just Docker images that encapsulate common things that you need to do when you develop AI systems, right? So obviously you have LLMs, so inference servers for LLMs. Uh, you have also vector databases. They have several stuff. So what we see in this chart is basically a basic RAG system. And the idea, and what we
Hold on,
wanted to
hold on,
discuss
hold on.
is,
Let me explain more around this part
please go
a
ahead.
bit. Um, so the NEEM part, the NVIDIA microservices is also exactly like this. Was initially was started to serve the models, right? So the inference part. So OpenAI API, compatible API, right? So HTTP REST API, but also all the bells and whistle to download the model, to whatever, cache some stuff around it. So it's what I call the fat container. It was a In the beginning it was a very, I looked at it and it seemed very primitive, let's say, but they specialized this container, so they moved into uh, using this approach for containers into a lot of things. So in your drawing here related to yeah, the drawing related to, is this the OCR thing or not? Like, do you
Um,
see do you have this no, agent does, no. So we will look at another one maybe later.
mhm. Feel free to share it, Marius. Feel free. Just take it from here because
Give me 1 second. Give
I
me 1 second.
yes.
Present. Yes, this one. Yeah. So you can see my screen. I think so.
Yes.
So recording. Yes. What you see here is the cloud of NVIDIA, which is called Brev now. If we go to the yeah, NVIDIA blueprints, whatever.
I'm gonna find the link and put it on the chat.
Yeah. Build NVIDIA blueprints. This one, yes. So the blueprints is a collection of yeah, ways and code how to deploy stuff. So this blueprint became is a collection of these NIM agents, sorry, NIM components, right? And basically, I'm trying to. This is the thing that I'm trying to explain. Um, so this NIM thing in the end became a little bit more complex and complicated. So they specialized one of these. If we look at them, the first one, right? This is a NIM container. I would say we can call it a container, a NIM, yeah, a NIM container, which is I think we are looking at a model right now.
Yes.
But this model, so this deploy model, right? You do this with create this name service, but this is a container like we were discussing last week, right, or 2 weeks ago. This is a Docker container. So basically, this is the NIM infrastructure. Sorry, this is the NIM structure behind plus the model attached to it. So they specialized into this, and basically all these blueprints contain Lego pieces. This is, I like this approach a lot. I would do it also in the same way. So these Lego pieces are here to put them together in a system like this, like we were discussing, right? And one of them does this, one of them does that, whatever, any other thing. So
And for example,
yeah,
yeah, let me say in this chart, for example,
yes,
the green elements are NIM containers. Each green element, I guess it's a NIM container, uh, or they are repeated
yeah,
ones.
exactly,
Memory. Mhm.
yes. So these are the containers, and uh, one of them does things, one of them doesn't do things. Yeah, so all of them are listed here. So this is the software used in the blueprint, right?
Mhm.
And basically they also did, so they looked at these blueprints. We were looking at this blueprint, and one of these blueprints that is like the foundation of everything, they also have a RAG blueprint. So this is
Let me find it.
the part which is here, I think. We were discussing the exploded is here, right? So sorry, this one, the RAG part, right? Let me put it in here.
Mhm.
So this RAG pipeline, we can yeah, you can see it's has also a lot of yeah, technologies inside, right? So all of this is in the, probably all of this is in a container, or like sidecar containers related to it. So it's as you can see, right? It's a re-ranking, a retriever, so
Mhm.
embeddings, re-ranking. So this blueprint is made out of a lot of small ones in the end, right? But this is uh, yeah, this is the way to go from there. And I like that they even put what do you need for this GPU, right? For Kubernetes, you just need 800 H100. So there you go. This is very it's very it's a lot. It's a lot. And
But the thing
we
is
can,
that
yeah, we can discuss later to in this towards the end we can discuss where what goes where if you want later, related to this part. But I also, if we go to this blueprints part, I also topped out my account with some 20 euros. Maybe we can even start one on their cloud, so you can see
Mhm.
right now what is going on. So we were looking at this. Are we were looking for this biomedical or another one?
Mm,
Which one was the simplest one we were discussing? Uh,
I think that the biomedical was the
yeah,
simplest one. Yes, because
this one.
yeah, this is the one I showed,
Yes. So
which
this one is what? This one wants what? This one we don't know what it wants. It's just architecture key features. Other software reference. Ah, okay. So it wants some disk space. Okay. Oh yeah, and here is the yeah. This is also the. This is the one that we were discussing. Yeah. So we were saying that we are going to break down, but it is already here, broken down. Like why who needs what, right? So the retriever needs this. The whatever the instruct report generation needs this, the whatever. All these things are, and I like that they say I need this or I need that, right? So it's very nice. But we can see if this one. So you can see here deploy on cloud, and then we go to their cloud, and this is a launchable in the end, and we can look for we can see if what is the so this is three as you can see this is 3 per hour, right? $3 per hour. I think in the end we will get a Jupyter notebook that it's going around, and we can see what is going on. But we can try to see if it's how it is going to look like. The notebook, I think it takes me to. No, sorry. Yeah, it takes me to this Python. Yeah, notebook. Okay. Deploy. Let's see.
okay, virtual.
Go to
Let
the
me
instance
sort.
page. So we will wait. Uh, the what I was trying to say related to the price is that this one is so 3.5 on their cloud, versus if we look at we were looking at this part, right? So this 8 or 5 800, so 5 800 if we go to Paperspace, console.paperspace.com, yes, something like that, where my lovely machines were in the course. If we want to create a machine here, then multi GPU, this is I only can find 8 times 1 H100, or let's see if 8 or no 5, or they want 8 A100. Okay, so A100 is where 8100, this one. So it's 25 per hour, right? Versus 3.5 per hour. So this you get one, what, yeah, multi GPU machine, right? So it's not a multi node. So you have, this is a Docker, sorry, this is a virtual machine. You have to, everything is installed in terms of drivers and you can use it, but you have to all work all your way out from here, like deploy this in there and try to figure out everything from the Docker Compose part, because this is not a Kubernetes deployment. I also think here they are not deploying Kubernetes at all. I was just discussing also with yesterday with somebody. Sorry, I don't know where it is. Let me see. Oh yeah, here. View logs, building VM mode. Okay. So yeah, so as you can see, is like a Docker, single Docker host, which is okay in the end. But yeah, I was expecting a little bit more from here in terms of running it. Um,
What instance is that?
this is a L40S. I, they say and then they are deploying on this Crusoe cloud provider, which is something else. So they bought, they didn't bought, but they linked a lot of cloud providers, GPU providers, to where they probably ship hardware. So if we look at yeah, so if I open a new tab here, GPUs, right, and I want GPUs, you can see here. Uh, so they've linked Lambda Labs, which I was working with before a little bit. This is Oracle Cloud. Nebius and Crusoe are some independent cloud providers, and AWS and GCP are the traditional ones. So basically, it depends on what you want. So I want 48 gigabytes of RAM, of VRAM, and any vCloud. Then you can see you have a little bit of, yeah, only something like that, right? But if we look, yesterday we were looking at this, right? So look at this. This is what I was saying. So this is 28, right, on Lambda Labs, and basically, yeah, okay, flexible storage is the difference, but in the end, it's 111, right here. So this is the 8 H100. So if we need it, we're gonna use the Lambda Labs one. So this one you can also like do this and launch it on the Lambda side, which is quite nice. Um, Basically, they made an API and everything else relate like with these cloud providers. And what you can do is do this VM mode, which I always like to do because you get full access to the GPU and everything else. You can install things, whatever, if you want to install things, switch the driver. Featured containers is pre-built containers from them. I think it's a virtual machine with a lot of pre-choices being done. Docker image, custom container. Yeah, this is I think it's going to be run on the machine as a Docker container, which is fine. And the Docker Compose part is also the same thing. So yeah, if we go to the to my organization, let's see, deployment,
But
launchables.
this, but basically they integrated with these cloud providers, with these GPU providers,
Yeah,
so you can run standalone Docker containers or groups of containers with Docker Compose inside one virtual machine, right? But they haven't made this thing like Kubernetes.
no, this is the discussion that I had yesterday with somebody who's who's working with, who is producing Talos. That they basically it's yeah, they didn't go to this far, to this step yet, and I I was hoping that they do, but they're not. They didn't do it.
Yeah, because I mean, this setup is fine if you want to experiment, right? What we're gonna do now, we're gonna rent a GPU for 30 minutes. We're gonna
Yes,
spin up the server. We're gonna see it works, and that's fine. But imagine that this is the LLM server, basically serving predictions for your, I don't know, a client-facing system. I mean, you're not gonna have things in a VM running in a Docker container, crossing your fingers, things are working.
yes, yeah, yeah, yeah. But in the end, as you can see, I'm I'm defending a little bit this approach. In I'm not sorry. I'm defending this approach because of this is a very approachable way of doing things for a lot of people, right? So you can understand what is going on here, and you can debug it a little bit, right? But of if if it's a production system or not, yeah, it's not. I don't think it's a production system, this one. So as you can
Mhm.
see, we have some Jupiters here. Yes, let's see if I can.
Yeah, but it's true. It gives you like a very fast way to actually run their NIM containers. So basically, run the building blocks you need to start building, for example, a rack system.
Yeah.
Um, because at the end, everything is Docker containers, right? But the thing is, how do you make run these Docker containers on the right hardware, right? And then you start.
Bas
I mean,
so
it's not a trivial
yeah,
problem.
that's the thing. Like basically, that's the problem that I have, and this is coming to your to what you were exactly saying right now. So we are looking at if we're looking at this table, let's make it a little bit bigger, right? All these so recommended GPU, right? What we are seeing right now with my deployment, I think I'm smelling it because I also was looking at their code base and how it does and what they do in respect to how should you deploy fully standalone, self-hosted. Um, so a lot of these things here, all the buildings blocks from here, like sorry, from this part, right? Something from here is being already deployed in their cloud, and they're using an API towards it. So this is the explanation why this is just a very shitty machine in terms of it's not shitty, but it's a whatever. It's a very two GPUs. Um, it's a very low spec machine, right? In
Mhm.
terms of the on this, and yeah, this is a container. And give me 1 second to scroll a little bit up because I see some errors. Yeah, so basically, as you can see, they're downloading all kind of things, installing the Python dependencies. It's yeah, not a very. Let's see the content of this. So the if you go back to this part, what they recommend here, so like 5 times H100, I would put them into deep, in a Kubernetes cluster which has access to this 5 H100, right? And all so you can replace them and you can manipulate them however you want, and this is something that we will have to also deep dive into, like how can we how can we make a POC, a working POC with a smaller model or with a smaller service. This is what we were discussing yesterday. So um, this ampere, this is the single ampere, whatever. Uh, um, this is the GPU that we're using right now. So only this is being used. The rest, I think they're using their own cloud deployment API. Basically, this is it. But if you want to get a little bit more serious about it, we can go to the so deployment options. You can see here Docker or Kubernetes, right? So if we go to Kubernetes, they have a pretty good setup, and you see that you can deploy all these things. So basically, yeah, the NIM, what NIM microservices, Baidu NIM, Nemo microservices. This is a new thing from them. Um, so all these things are being deployed. As you can see, they're deploying all these things are see the Milvus database, Minio is there. Maybe this one you can extract and have it as a Lego block, but this is the thing that we were discussing related this is what I wanted to show you. So they specialized NIM container into this like retriever, graphic elements, page elements, table structure. So remember, Paul, we were discussing about parsing a document, right? Like a PDF for our agentic system. Probably we were gonna look how they use this and what they use inside, because these are highly specialized agents to parse a document, for example, right? So to understand a graphic or a table in a PDF that we feed to our agentic system. Also here, there's a lot of models. So the Yama model, and there was also the Baidu thing. I don't see it. Yeah. Then there is Redis. This is cache. The rack server, probably something, we have to look into. Also, the re-ranking NIM is also a specialized NIM again. And Zipkin is just a tracing part that they're using for tracing things around. So this is also very important from an observability perspective. So you can see they moved from, so open telemetry collector. This is this is going to send data to Zipkin. So they completely, I don't see Prometheus here, so they completely dropped Prometheus from this part from observability perspective. Zipkin is an old school friend from the Java world. Is a distributed tracing system. If we look at it, you can even yeah, you can even send trace signals from the code base, from whatever, everything, something like that. Am I still there? Yeah. So
Yes, you are.
so yeah, sorry. I thought sometimes I need some
Mhm.
feedback sometimes when I'm speaking 10 minutes over. The what we can go back to the. Let's see if we can open the notebook and see what is going on.
I only wanted to say that in these rack systems, what I see is this. Um, they are very heterogeneous. So in a rack system, you need LLMs for several functions. One of them is reasoning, which is the first step, which is you want to understand what the user wants, right? There's a first step of understanding user intent, and then doing something called tool selection, which means, okay, to answer this question, I either need to check this internal database where, I don't know, biomedical research is available, or I need to go to on the internet and do an open like a general search. So there is first step, which for that you need, let's say, a smart model. And a smart model means, for example, Llama with 70 billion parameters. Sorry, my kids are shouting, right? So for that step, you need this LLM. But now, once you have decided you need, for example, to get data from a database, and you need to do the embedding, re-ranking, and that, there are other LLMs which can do the job as well as Llama 70 billion does, but they're way smaller. So they're cheaper to run and cheaper to operate. So what is happening now is that these rack systems, you could just use one LLM for everything, right? You could just deploy one pod with Llama 70 billions. It would cost you a lot and do everything. But what people find, which is more cost effective, is to basically have specialized LLMs for different parts, right?
Yeah.
And this is something that now companies that started deploying things realize that, yeah, it's more convenient, right? But it's also more complex. So this is what we're trying to tackle here. Okay, it's a better idea, but you need to know how to do it well. And this is more or less the whole thing we're talking today, which is
The Kubernetes part is very so the, how they describe everything what we were discussing in the Kubernetes part, like in this deployment. I think they envision that that's a first step to a production system. Of course, all of that has to be um, um, let's say scaled up and understood how you distribute the cache and everything else. And I had let me share the screen one more time because I will show you something that I just, so we were discussing yesterday what are we going to discuss, and uh, we were discussing this rack system. So AI bricks, do you know, did we discuss about this, Paul? No, I don't think so.
no.
So AI bricks is a thing that came from TikTok in the end. um, Give me 1 second to AI breaks KubeCon. Yes. I'm gonna share this page, this video. so everybody can see it. Basically, the alternative to NIM, to NVIDIA's ecosystem, they came up with this AI Bricks, a cost-effective whatever, for VLLM, with everything inside here. Like we were discussing about whatever the basic elements, like things to specialized things to read documents, specialized things to do this, that, whatever. And if we look at the architecture, you can see like all these things are so this is the NIM part from NVIDIA. This is the equivalent of the NIM part. There is this model loader and runtime agent, whatever, watchdogs for all these things. Plus you have a lot of ecosystem around it to distribute all these things to support the distribution of these things, right? So you need S3, this is media probably. You need the KV cache. I was just looking into this morning. This is Redis in the end. You have all kind of whatever HTTP infrastructure on top of it for whatever, all kind of things that you have to do around it. You have whatever, all kind of control planes if you want to. They specialized in this control plane, but all of this is open source. Sorry, here. And yeah, AI Bricks. It's a very it's a Python. Give me a second. Deployment. Yes. So it's a Python. Thing. That is a very like it's very coupled. All these components are heavily coupled in between them. I'm waiting for them to decouple a little bit, but this is also something that probably we will look into to understand how. But again, taking a step back, this is deploying VLLM in the end, and NVIDIA NIM has moved away from the VLLM part because it's a little bit of Python hell there. It becomes a Python hell, and in terms of performance, people are commenting that this being so they open source this because it's way easier to ask people to fix your things. There is a lot of duct taping around here in terms of scripts, Python, and let's say infrastructure components. So probably they did this just because to understand what is the next step for them, right? But this is also like we didn't show anything related to the NVIDIA ecosystem systems diagram. This is what it looked like in real world, right? And there is a lot of duct taping around all these systems, and probably a lot of performance problems around what is in here related to Python. That's it. I'll share.
How is our deployment doing?
Let's see.
But what it feels, different companies and different initiatives are somehow trying to bring this.
You're muted. Internet is gone. Or your headphones are gone.
Sorry, guys.
Your headphones are gone?
No, my internet is gone. No,
okay.
It's fine.
That's okay.
Hello.
Yes.
No, I was saying that what it says, what we're showing, basically, I'm trying to grasp the trends here, right? Because what has market value? What are companies like struggling with at the moment? And I think this is precisely what these two options, NIM or AI Bricks, try to tackle, and what we are talking about today, right? Which is we know the software part. We all know we can all learn pretty fast how to write a Python program that orchestrates these rack pipelines and so on. And we know we need to ingest documents, and we know we need an LLM to send the prompt, enrich it, and blah, 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 and return to the end user. But then it's super easy to do these things when you're making calls against OpenAI or Anthropic, right?
Yeah.
And then you go to your company, and your company, for example, is a bank, and then they say, "Oh, I know how to build rack systems. I think we should build one." And the first thing you realize is that basically all the things you were building on top of which are not available, and they will never be available in a bank because there's no way they're gonna let you use OpenAI or Claude or whatever, no matter how amazing these APIs are. Like they don't allow you, sometimes even because of, well, they don't allow you. So the question is, how do you implement these things on the enterprise, right? And this is when you start finding all these problems that these different initiatives try to solve.
Yeah.
And I'm saying this because here we're talking about the solution, but it's important to understand what's the problem, right? Why these diagrams, why these spots, why these Kubernetes, why this thing? Well, because many companies, this is the only serious way to do that. And sooner or later, they realize that part. Okay, so um,
So
I'm saying
our
this because
deployment is there. I've
Mhm.
activated everything related to. So these are this is not a this is a beta feature and cannot. Okay, so yeah, okay, no problem. So we cannot SSH inside. So this is I don't like this at all because you can't hop into the machine and see what is going on. But let's see how what is in here. Why Yeah, so machine. This is a virtual machine. I can tell it for sure because it's a. I see this Linux system D logging. They have it's probably a Ubuntu machine. If we look at it from the beginning, no, we can't see all of them. Open notebook. I opened the notebook. I was running everything there. So this right. Uh, Let me run it again. Maybe if I was, what is happening? Run, run all cells. Sorry, this was the.
Hi, Marius. We see here you're not a data scientist who has spent
Yes.
hours, days, weeks
Yeah,
going
I know
scrolling.
that if yes, you're right. You're right. You're
No,
right.
you're a lucky guy. You didn't have to do that.
But I'm not that lucky because I had a lot of, I had to deploy this Jupyter thing in a container a long time ago. So I know all of this stuff related to um, running them. But I hoped this is run everything, like the play button.
Yes,
But it's
yes.
only run the cell. But still, we don't have anything in here. So what is happening?
Now, at the moment, there is nothing. So I think there's a run all. The things that there are some values there that I think we should introduce, I guess, or this
No,
API key.
this should be like everything is in here. Like
Okay, so no need for that.
yeah,
Then I think you can just go at the top run and run all. There should be an option.
yeah, I did it. So run all cells.
Yes.
So
Then it's
let's
fine.
restart the kernel and
Okay.
rerun everything.
Yes.
That can be something.
Mhm.
Yeah. So as you can see, it executes a lot very fast because it's not it's not a slow laptop, but yeah, I don't want the yeah. So it's progressing, but we don't see anything. I don't know what is going on. So follow the instructions on a demo walkthrough. Okay, so we need to get into this UI in the end for the right to understand what is going on. But probably one of these let me see access. Yeah. So this is the Jupyter, okay, and then the ports. Let's open them one by one. This,
Maybe 3001 is the UI.
yeah, I think so. Yeah, let's see.
Nice.
Expose port. I don't need to expose all the ports. Oh, this is a yeah, okay. Allowed from any IP. Yeah, so it was there. It's there. So we can talk about things and yes, now as you can see now it's pulling all these images. Yes. So yeah, but I hate this. You're using a Python a Jupyter notebook to control the system. I really hate this part.
Well, welcome to the world of data science, Marius,
Yeah.
in which you run everything. Everything is running in one computer, in one magic computer, and everything are cells,
Yeah.
and you never know what has been run so far and what needs to be run, and where it crashed and why. And when you push it to GitHub, there is no way someone will understand what are the differences with the previous version of the notebook you just pushed 5 minutes ago, writing a GitHub commit message update.
Yes.
So
Uh,
welcome to the real world.
yeah, the real yes, exactly. Yeah, yes. It's okay. We're gonna figure it out.
But, but basically here, what you're doing is running a Google Colab
Yeah, yeah,
on your own
yeah.
virtual machine, right? So you spin up the VM, and you spin up also the model, or and now you also spin up basically a Python process, which is the Jupyter server with this notebook, and now you're triggering with the Docker build and Docker run. You are trying to run all these containers you need to run, which are all these LLMs. And
Yeah,
this thing takes a
re
while
yeah.
because yes, some of them are quite heavy.
It's gonna, yeah,
Um,
as you can see some things appear here, so they clone some things. Uh, let's see how it goes. Yes. Right, and then the rag is this part. So the rag is what? The rag is, yeah, exactly
there's a
what?
long chain.
Yeah.
So I guess the logic, so basically LangChain is the Python library that is used to orchestrate the steps of your RAG system.
Yes.
So you read the user input, you send it to the retriever, then
Yes.
you re-rank, then I mean sometimes there's even like this thinking process in which you send the response to your LLM and say, is this good enough or not? So basically you add sometimes mm, let's say non-fully deterministic paths. And you use LangChain, you use LangGraph, but this is this lightweight. This is just the orchestrator layer. But
Yeah.
the heavy stuff is are all these Docker builds that you're doing.
Yeah, and I open this Docker file, and you can see here what they're doing, related to what is going on here, and they're using UVcorn. It's okay, I would say. Um, and what else is interesting here? That's about it. Python 3.10. Okay, that's a very very old one. Um, It's all from Pau's cohort number one. Okay, and what else? What else? What else? What else? Let's see this one. What is going on? Yeah.
I have a dumb question, guys, regarding uh, what's the most popular database, vector database that you guys are using to run a reg approach, like ChromaDB or something like that?
So these guys from Nvidia are using Milvus,
Ah, meu.
and they also this one, which is GPU. Yeah. Who CUVS, this one. Do you know this one? I will share this. I will share this
Okay,
article.
great.
So CUVS vector. So on top of Milvus, they use this CUVS library.
Mhm.
This is something that we were looking at it even a couple of days ago. And yeah, as you can see, it's CUDA related. And
Yes.
Raft Raft is a protocol that is being heavily used in distributed systems right now.
Mhm.
And this would be something that NVIDIA uses. They choose to use this. So if we look at here, if you can see the screen,
Yes.
so when the RAG is doing a vector database um, interactions, right? So
Mhm.
the content, this content, the embeddings content is pushing. Probably if you have more of this, or if you have more of the re-ranking part, that's the most interesting part, because this is we were discussing that some of these pipelines, we can call it a pipeline, it's a feature pipeline. Some of the pipelines are offline or online and online, right? So the re-ranking should be done asynchronously in the end, or we were discussing this how we would do it, right, Paul, or not?
Yes, what I don't like of this chart is that if you click on this rack pipeline, it looks like there is one pipeline here, when in fact it's two different ones. So
Yeah, so
there
the
is one
extraction
pipeline.
embedding to the vector, and then the re-ranking, whatever. This should be a little bit, yeah. So the re-ranking is coming from the vector database, and then they want also like this generate re-ranking is also a pipeline, right?
Yes, I think this is one of the basic design principles that we use. I mean, that we use in all courses and everything that I do is you break down the system, any machine learning system, it doesn't matter with LLM, with three different things, which is generating data and storing that data, generating machine learning models, which means training them or fine tuning, and then serving predictions. These are three different things: feature, training, inference pipeline. And in this chart of RAC, there are two pipelines that meet at the data store, at the vector database. There is the data pipeline, which can run offline. So let's say it can run once a day, or it can run on demand. So for example, imagine you have basically you have a UI where users can upload documents. So I don't know, you work for a car insurance company where agents use some RAC assistant to speed up the whole process, right? And they just onboarded a client. So they collected a bunch of documents, PDFs and stuff, and they want to store this data internally. So what they do is they go to the UI, they upload the PDF, click. And when they click, what triggers are the first two containers
Yes.
of this pipeline, which are doing basically the extraction and the embedding. So this pipeline works on demand, right? It works whenever data is available. Now, the other part of the pipeline is how to use this data. And this is a real time. As soon as this agent or another agent requires some data regarding this, then this thing runs whatever. So what I'm trying to say that this graph is a little bit misleading. This is not a rack, meaning one pipeline. These are two things that work at different frequencies. The point where they
Yes.
communicate, where one leaves the data and the other one uses it, is the vector database. And I also want to say something that, in my experience, I think people are very framed with databases, like vector databases is the thing to do everything. And this is true when you're building a conversational bot, where the questions are quite open and basically are human phrased. But for other systems, there is no strong reason why, if you have a Postgres database with all your data, you should not put everything in a vector store and then do the RAG. you can build a rack on top of Postgres, for example. So I'm just saying this because there's a lot of like vector database. I mean, it depends. If you're storing, like, for example, images, text, and stuff, yes, it's a good way to have everything under one hood. Oh, buzzer. Sorry, guys.
Yeah, and also, may I add something? The whole RAG approach, the naive RAG approach, which is basically chunking and embedding and then doing a vector search, as you say, is limited for most cases, except for like simple chatbots or anything. Sometimes you will need to have your RAG system is maybe using an agent to generate a SQL statement to fetch something from Postgres. It doesn't need to be a vector, or sometimes you need to build a graph, or maybe you just want semantic search, or maybe you want a hybrid. It's really down to how your system is supposed to be used. So you should rather reverse engineer from the questions or the inputs that your system will receive, and then think of what your RAG pipeline should look like, as opposed to using just the simple naive vector search based approach, which is it was super hyped last year, and now we see that it's like super limited. It's just good for chatbots, and not even. It depends on what chatbot we do.
So what is the
So-
alternative that you can describe to this?
Sorry, say again.
What is the alternative?
Well, it's usually, I mean, if you want to implement something like works in a very sophisticated environment, which is usually most companies, then it's going to be a custom thing, and you have to combine things. You will usually need some sort of agentic mechanism to decide what kind of RAG to do, but it's going to be a combination. As I'm saying, maybe you want a LLM-based SQL generator to fetch some data from a Postgres.
All these things
and
become very highly,
Yeah.
let's say, specialized. Like there is no
Exactly.
silver
There-
bullet for everything.
Exactly. There's no silver bullet. It's really,
It's like a web
you need
framework.
to,
It's
yeah.
it's a
You-
web
you need
framework, and
to-
you have to do the implementation of everything.
Exactly. You need to know. Actually, personally, I find the original naive RAG concept rather detrimental, or it's not a good mindset. That's why now you have this concept of context engineering arising, which is
Yeah.
basically saying, okay, we cannot just go and fetch chunks based on vectors. That's obviously limited. We need to truly consider this form of engineering where we design complex RAG pipelines or context fetching pipelines that fetch in different ways and combine them in different ways based on whatever your system needs. So yeah, there's no a single answer for it. It's really down. This will definitely become a whole form of engineering, and the value of the system you're building will be very much tied to the value or the complexity or the sophistication of these pipelines.
Yeah. Exactly. Yes.
Mhm.
Exactly.
Yeah, for me, the value of the system will be directly related to whether in this context you are adding what you need to add, the information the model needs or not. Like I really like what you said. I think LLM engineering is context engineering, which means
Context engineering. Exactly.
LLMs are really good at doing something if you provide them enough clues, so enough information, enough context. So your job is not going to be touching the model internals. You will rarely
No.
be fine-tuning an LLM but your job will be 90% of the time making sure, so passing the context the LLM needs, debugging the context is there, understanding when it's not there and when it's not, why. So you basically change your workflow, and then you, as you said, instead of a naive RAG, you realize that you need a more sophisticated, let's say, multi-step process. So yes,
Exactly.
this is where we are going.
And so you got it totally right. So basically that implies that the model itself, it's definitely a commodity that can be abstracted away. It doesn't really matter. That's one thing. Then the quality output is going to be down to two things. One, the quality of your data, of course, and then the quality of your mechanism, right? And then the third one is exactly what you said, context engineering. So it's going to be about like thinking of a prompt as a dynamic thing that it's built each time in a way that it can be like super complex, and that's what's going to determine the quality of your output. And exactly, like the fine tuning and or touching the internals of the model, it's really something that makes sense in an optimization step way further in your system design. When you find, for example, that there's a single step in your whole workflow that is something that you want to optimize because, I don't know, you're doing something simple, or you know exactly what it is. For example, let's say there's a step where you structure an address. Okay, that's very straightforward. That's never really going to change. So maybe instead of using GPT-4, maybe I will distill a Llama model that is only 8 billion parameters, so I reduce cost and latency. But only those cases really make sense for fine tuning. All the rest, it's really context engineering.
And
As you just said.
what I would like to throw another anchor to what you're saying related to the engineering part. I'm sharing on the screen this. I was looking at like how they cache things related to these guys from AI Bricks, related to the VLLM and related to VLLM. Mostly they use this key value cache, distributed key value cache throughout their whole stack, right? It's not only the model things that is using, and basically it's you have to understand a lot of things of distributed systems here also. They have this even whatever, and Infinistor is a let's say Redis like thing. And all these things are like RocksDB is a local one if you want, whatever, or HP key value. This one, this is the most one of the most popular one, I would say. So as you can see, they tried a lot of things, right? So in terms of how we are going, okay, we need cache, we need cache, and then okay, we need to distribute this cache among our things, right? If you look at our tryout right now with the Python thing, which is a one node, why do you need cache for that? You don't need the cache because it's a one node Docker compose everything, right? You don't really need a lot of cache. Yeah, okay, some cache related to the upper parts of the stack, but overall this has to be dissected a lot, like to understand what is going on and what can be done with it, right? But in what I'm trying to say is that I'm looking at this system as a Lego kit. Like I'm always looking at things, right? Can I extract these things and reuse them in other parts? This is a thing that I'm looking at all the time. Like this seems very tightly coupled in the end. While the NVIDIA one, you can navigate. This is what I like. We can hack around a little bit, reuse a cheaper model or a less sophisticated model in the beginning to understand if we can run it on a machine, because we need GPU, right? That's the whole thing in the end. But as I see, going back to what Cristiano was asking, like all this, what database, what vector database? As you can see, even a freaking vector database needs a GPU, you know, like. So it's becoming like everything you need a GPU. It's becoming very, you know, like.
And honestly, I think that the concept of a vector database, which is super new and immature and still evolving, is going to like disappear because a simple vector database will just not be enough. So you see stuff, for example, like there are plugins for Postgres to do vectors,
Yes.
or
PG
or
vector.
for example, MongoDB has a whole set of new AI features where you can do like vector, semantic, even re-ranking stuff So I think that databases will evolve to include all these features, because otherwise we're gonna end up like using like 5 different types of databases for these systems, and that's obviously doesn't really make any sense.
Cristiano,
Uh,
also for Carlo, the PG vector is basically right now all the distributors of Postgres cloud, like cloud native,
Yes.
are using PG vector.
Good.
Basically, it's already embedded in there. It's a system. It's a whatever pre-enabled system extension for Postgres.
But
So you can
Like
get away
have
with
you
it.
ever heard that somebody using production this kind of plugins and all this stuff?
Yes.
yeah,
Oh, great.
absolutely.
Yeah. So
They are not as performant as a native vector database such as Quadrant, but they're usually good enough.
yeah, so
Okay.
you can
Uh,
get away with
at
one
least you,
database in the beginning for a POC.
yeah, yeah,
Uh-huh.
So
exactly.
Great.
SQL, traditional SQL, does you do 90% of that, and then the vector part you can also. Um, I know a project who somebody who used PG vector a long time ago, like 4 or 5 years, and it was even performant back then with a lot of data, vectorized data, and this vectorized search approach. What is the nearest thing, whatever. Um, it was not RAG related, but it was performant enough for. Yeah, of course.
Great.
If you aim to be TikTok, you have to take the you have to bite the bullet, right? But if you're
Yes, and also
if you want 5 users in the beginning, I think in a demo you can get away with PG vector, of course.
Yeah, and can also
Great.
consider that based on what I said previously, you will probably want to split your knowledge base. It's strange. I mean, or it's not really a good idea to put the whole knowledge base in a single place, because you can usually section it and then use some sort of agentic mechanism to decide where to look. And that way you reduce the pressure on the database a lot.
Yeah, of
You know?
course. Yeah.
Okay.
yes, and I also want to say why why databases gain so much traction in the last 2 years. I think that the problem they solve is they make unstructured data like images, text, sound. They make it searchable, right? Because they transform
Yes.
everything into a vector, which
Yeah.
is like a sequence of n real numbers. And they also provide a mechanism to find similarity with this cosine or whatever this is. So they make information representation and retrieval, let's say, universal. But sometimes you don't need that. Sometimes your information, like if your information is already in a database where you can perform regular searches, like your data warehouse, like you're a big enterprise, and your node database is in a data warehouse, let's say in a I don't know, S3 buckets, in CSV files or Parquet files. And then another source of data, for example, are PowerPoint presentations. Like when you work in enterprises, people love just create a new presentation. I create a presentation, that's it. This second source of data is what vector databases can help you with, because if you are able to basically chunk them, represent them properly using any of those models that basically computer vision to vector models, so basic image representation models like the ones Mario showed before, and you put it in a vector DB, now this is also part of your RAG system if you want, right? So this makes sense, but what doesn't make sense is precisely what Carlo was saying. You should not just say, oh, vector database is the place where my data should be. I should build a system to dump everything to a vector database and use it from there. No, this is not what happens. But if you're dealing with
Yeah,
videos,
vector databases should be regarded as a search index,
Yeah.
as you just said.
Yeah. Exactly. But you
and also I wanted to say something, guys, that is now we are
Great.
talking about context engineering and everything. Like when you look at the list, so when you look at the list of containers that Marius was showing before, here it is, of this RAG system, I mean, when you look at them, most of them are actually doing data engineering.
Yeah.
So actually, they're trying to prepare the data your LLM needs. So it's what I see now happening in LLM engineering is what happened in deep learning or in general in traditional machine learning 5 years ago or 10. Like 10 years ago, the job of a data scientist was the hottest ever. Like everyone wanted data scientists, the people who know how to train models
But
because they are great at
99% of the time you are doing data engineering.
Yes, and now you're hired in a company, and then they realize that the superstar data scientist is not able to build something that works. Why? Because he ends up or she spends 90% of his time or her time doing things he's actually not so used to, and he doesn't know, which is data engineering. And now we go to the data engineers. Now with LLM, it's happening the same. It's what Carlos said. The models
It's the
are
same.
there. There is no one really. You don't need to know how a transformer works. You don't need to know really the internals of an LLM. You don't need that, honestly. What you need to know is the engineering to prepare, store, and serve the data this model needs, and basically iterate on that. And this is data engineering again. So this is good. I think data engineering is the most, let's say, the safest job for the next 10 years. Honestly,
Yeah,
people who
and
know how to prepare data that these things need. That's it.
unstructured is the new black. I mean, it's just going to be like that. You need to learn to build unstructured data pipelines and store them in a way that makes sense for your system. Exactly. That's exactly what it is.
Yeah, but as you can see, like what I to add something from an infrastructure part, I like these guys that from Nvidia that they went with Zipkin. Like it's fine to not understand like whatever all these Prometheus metrics and errors and whatever, all these metrics from the DevOps world, like golden signals, Dora metrics, other things, right? um, and then go straight to the part, to the meat, where is like let's see how this, where this fails, because it's very important. This fails, as you can see on the screen. I'm, like, nothing is working straight off the box. Like we don't have a seamless Apple like experience, like I'm saying, right? We're still waiting, and they decided to go with Zipkin just to add this tool there for you to go into the trace of everything. So basically, from the initial part of the system, you get an ID. That's the tracing, ecosystem. You have a UUID. Your request gets slapped with it. The beginning of the request, like when you're saying, here is this document I'm uploading. I want you to parse, and I want you to interpret the table in page number 5 versus the table in page number 10. Boom, that's the prompt, right? That request, the initial request, gets an ID, and then that ID is being traced, being labeled. All these things are being where you can label calls in the system and extract telemetry for them, like error logs or other things, right? You send them to Zipkin with this ID. So basically, you have a breakdown of all these things that is happening, right? In terms of database calls, in terms of whatever interactions with other systems. That's why it's important, and it's like it was regarded as a like a golden thing in Java based companies. They have them. 1 in 5 companies had tracing. Now I think it's going to be even more, because the systems are getting even more complex, as we see, right? You're muted, Paul. You're muted.
Sorry, guys. I said I'll have to go because I have 2 young kids full of energy who are going to destroy the flat. But if you wanna have a second coffee, just go ahead. Okay, I just want to communicate that.
Yeah,
No,
I'm
I
gonna
have
go
to.
copies because it's
I have to go.
there is some errors. I have to debug these errors for sure. As you can see,
Oh,
I have
it's
to
not
put
working
something
out of the box.
production.
Sorry.
It's not working out
I
of the
have to
box.
put something production.
Yes.
Oh.
Holy system. Oh man.
Yeah.
A payment gateway
Yes.
that I have worked in last month. We are putting in production.
Well,
Nice.
good luck.
Thank you.
Nice.
Okay, guys. It was a
Bye-bye, guys.
pleasure. Yes.
Bye bye.
Talk to you soon. Bye bye.
Bye.
Ciao.
Bye-bye.
Bye bye.
Bye.